Hello everyone and welcome back to the Leetcode grind. Today we have 2559 count vowel strings in ranges. It says here you are given a zero indexed array of strings, words, it's a list of words, and a 2D array of integers, queries, which is just a list of two values, start and end. Now each query here asks us to find the number of strings present in the range of L to R, both inclusive of words that start and end with a vowel. Vowels are these, A, E, I, O, U. And we are to return an array ands of size queries.length. So we're satisfying each query where each ands of I is the answer to the ith query. And let's actually look at the second example first. In this case, we're given three words. They happen to be one character each, and they happen to all be vowels. And so when we query for the full string, we return 3. If we query for the first two strings, because remember these are inclusive, left to right inclusive, we return a 2. And when we query for just one string, in this case 0 index, 1 index, 2 index, if we just query for this string, well, yes, that's a vowel and there's one of those, so we return 1. And that's simple enough. And the strategy we will use is called prefix sum, and that is where we calculate for each word in the list of words, does that satisfy the condition, which in this case is where the first and last string, the first and last character in each word, in each string, is a vowel, where they can be the same. The first and last may be the same character if the word is a single character length. And let's actually run through this example. So here we see that there's 5 words where the first one satisfies. So true, false, true, 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 false, true, true, true. Okay, so let's replicate that. So let's say that we have true, false, true, 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 right? So let's see, we're gonna say, well, that's a true. False would be like that. True, false, true, true, false, true, 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 right? So the values don't matter, we just care that, this is basically true, nope, true, true, true. And then we're gonna have a prefix sum. So prefix sum, PS, of whether this counts towards our total points, let's say. Well, here we see that it's valid, so that's 1. Not valid, so we just carry over the previous one because we're counting the prefix sum. And here it's valid, so we get another 1 added to the previous one, so that's a 2. This is also valid, so we get 1 point for the valid one, and we increment by the incoming prefix sum of 2, so that's a 3. Here, once again, it's valid, so we add 1 for the valid one, but we also inherit the incoming 3, and here we have it. So this is the list of prefix sums, and now we can check against this list of queries, which is 0, 2, 1, 4, 1, 1. Okay. So 0, 2, 0, 2, 1, 4, and 1, 1. Well, 0 to 2 would be, if we do 0, 1, actually let's do the indices in this color. 0, 1, 2, 3, 4. And remember, these are inclusive. So 0 to 2 would be here. We can say, well, at the ending range, we have total 2. And we want to exclude anything that comes before 0. And, well, nothing comes before 0, so we can just exclude 0. And that would equal to 2. If we do the range of 1 to 4, that's actually here. And remember, this is inclusive, so we count everything. Well, we take the final count at the ending range, which happens to be 4. And now what do we subtract? We subtract what comes before the 1, before the start, right? Because it's inclusive, so we subtract at the start index minus 1, which is this guy. So we subtract 1, and that gives us 3. And finally, let's check the range of 1 to 1. So 1 to 1 is just this guy. Well, what's our total at the ending range? It happens to be 1. And what do we subtract? We subtract whatever value we accrued before we reached here, which is 1. So we subtract 1, and that is 0. And so 230, does that match our expectation? 230, yes it does. So why don't we implement our code here? Okay, so what did we do? We had a prefix sum, which we're going to generate now. And then we'll also have some result, the query result, right? And then we'll add that. And let's build our prefix sum first, where we say for, and well, you know what? Actually, let's also say vowels is going to be a set. And the way we can initialize it is just like that. So A, and we're doing set, doesn't really matter, but AEI, just so that we get O1 lookup time, OU. And we are guaranteed that each word consists only of lowercase English letters. And there is at least one query, and the word may be empty. Interesting. The word may be empty. And no, the word cannot be empty. The word, it has to have at least one character, and there's going to be at least one word. Okay, gotcha. Now let's continue. So for word in words, we can say if word of 0, and we won't get any index issues because we're told that each word will have at least one character and there will be at least one word in words. So if the first character is in vowels and the last character is also in vowels, then we can say cursum. Cursum starts at 0, and we can say then cursum can be incremented by 1. And whatever this cursum ends up being, whether we incremented it or we did not increment it, we're going to add it to our prefix sum. So prefix sum dot append per sum. So as this grows, we're going to carry that over to our next word, whether it's incremented or not. Okay. And then after we append it, at the end of this, we'll have a list of prefix sums. Basically, we'll have this guy right here, this row of prefix sums. And then now we can search for a result, which is we're going to process our queries. So for each query will contain 2 values for the start and end of inquiries. Sorry about that. For start and end inquiries, we'll say now the value we're discarding will be the value previous to the start index, because it's inclusive. So the value that we're discarding will be 0 if the start is 0, because if the start is 0, there's nothing to discard, since anything less than 0 will be indexed out of bounds, and so it'll be 0. Otherwise, as long as the start index is greater than 0, we can discard the value in prefix sum of that start index minus 1. So whatever comes before that start index, we can discard it as long as there is a previous index to discard. Okay. And then we can add to our results. We're adding to our result. What are we adding? We're adding the prefix sum of our end. Alright, so whatever we have on our end range, so 1 to 4, if we do 1 to 4, it'll be this guy. So straight up, whatever we get minus whatever we are discarding. And then we should be able to return the rest. Let's give that a go and submit. And there you have it. Once again, and then let's see the time complexity for this. We go through each word in words. So that's O of M, let's say. So O of M. And then for each query, we go through each query. So O of M times O of N, which becomes O of M times N. Or no, M plus N. So O of N once here, O of N once here, so O of M plus N. And space is at, I think space is also O of one of these. So let's say that the words is going to be M, so O of M. All right. Anyways, once again, this is 2559, count vowels, strings, and ranges. Thanks so much. Happy coding, and see you next time.